You've seen solar panels on rooftops everywhere, right? But have you ever stopped to wonder how they actually turn sunlight into electricity? There are no moving parts, no spinning blades, and no fuel being burned. It's just light. It almost seems like magic, but it's pure science. And in this video, we're going to break down exactly how solar panels work in simple, easy to understand language. We'll dive into what photovoltaic cells are, explore what affects their efficiency, and finally, tackle the big question. Are they really worth it for your home? Stick around, because by the end of this, you'll understand this amazing technology from the inside out. So let's start with the basics. What exactly is solar energy? The sun is a gigantic nuclear fusion reactor, about 93 million miles away. Every second, it releases an absolutely enormous amount of energy out into space. This energy travels in the form of electromagnetic radiation, which includes the visible light we see. This light is made up of tiny packets of energy called photons. Think of them as little energy bullets, constantly streaming from the sun and showering our planet. In just 1 hour, the Earth receives more energy from the sun than the entire world consumes in a whole year. It's an incredible, untapped resource. Solar panels are designed specifically to catch these photons. Their job is to act like a net, capturing that incoming solar energy, and through a process we'll get into, converting it directly into usable electricity. This amazing transformation is called the photovoltaic effect, which literally means light electricity. It's a clean, direct conversion of energy, and it's the fundamental principle behind every solar panel you see. Now, let's zoom in and look inside a solar panel. What you see on a roof might look like a single solid piece, but it's actually an assembly of many smaller units called solar cells. These cells are the real workhorses of the system. Most solar cells today are made from silicon, which is a semiconductor. It's the same element used to make computer chips. The magic happens because of how this silicon is treated. To create a solar cell, manufacturers take 2 very thin layers of silicon and dope them, which means they add impurities to change their electrical properties. One layer, called the N-type layer, is doped with an element like phosphorus, which has extra electrons. This gives the layer a negative charge. The other layer, the P-type, is doped with something like boron, which has fewer electrons, creating holes or a positive charge. When you put these 2 layers together, the extra electrons from the N-type layer want to jump over and fill the holes in the P-type layer. This movement creates a permanent, one-way electric field right at the junction where the 2 layers meet. This built-in electric field is absolutely crucial. It acts like a slide or a slope, ready to direct any free-flowing electrons. This brings us to the core process, the photovoltaic effect. So we have our solar cell with its built-in electric field. What happens when sunlight hits it? Those photons we talked about, the little energy bullets from the sun, stream down and strike the silicon atoms in the cell. If a photon has enough energy, it can knock an electron loose from its atom, creating a free electron and leaving behind a hole. Now we have a pair of charges that are free to move around. This is where that electric field we just built becomes the hero. The field acts like a traffic cop, immediately pushing the newly freed electron towards the N-type side and the hole towards the P-type side. It separates the charges and prevents them from just immediately recombining. By forcing all the electrons to flow in one direction and all the holes in the opposite, the electric field creates an electric current. To capture this current, a grid of thin metal contacts is printed on the surface of the cell. These contacts collect the flowing electrons and channel them into wires. And just like that, we have electricity flowing out of the solar cell. Multiply this by the 60 or 72 cells in a typical panel, and you get a significant amount of power. There's one more important step in the process. The electricity that solar panels produce is called direct current, or DC. In DC power, the electrons flow continuously in one direction. This is the same type of power you get from a battery. However, our homes and all the appliances we plug into the wall are refrigerators, TVS, and chargers run on alternating current, or AC. In AC power, the direction of the current reverses back and forth many times per second. So, the DC power from the solar panels isn't directly usable by most of our household devices. This is where a critical piece of equipment called an inverter comes in. The inverter is the brain of the solar system. Its job is to take the DC electricity generated by the panels and convert it into AC electricity that matches the power standard of your home. It's a seamless, automatic process. The electricity flows from the panels through the inverter and into your home's electrical panel, where it can then power everything you need, just like the electricity from the grid. Now you might be wondering, how much power can you actually get? Well, the performance of a solar panel system isn't constant. It's affected by several key factors. The most obvious one is sunlight hours. The more direct, intense sunlight you get, the more power you produce. That's why sunny regions are ideal for solar. The angle and direction of your panels also matter. For the best results in the northern hemisphere, panels should face south and be tilted at an angle that optimizes sun exposure throughout the year. Shading is a huge enemy of solar. Even a small shadow from a tree branch or a chimney covering just a part of one panel can significantly reduce the output of the entire system. Temperature is another surprising factor. Solar panels actually work better when they're cool. As they get hotter, their efficiency drops slightly. Finally, things like dust, dirt, pollen, or snow can accumulate on the panels and block sunlight, reducing their output. Regular cleaning can help maintain peak performance. The overall size of your system, meaning how many panels you have, will, of course, determine the total amount of power you can generate. When you start looking into solar panels, you'll quickly find there are a few different types available. The three main types you'll encounter today are monocrystalline, polycrystalline, and thin film. Monocrystalline panels are usually black and have a very uniform look. They're made from a single pure silicon crystal, which makes them the most efficient type. They produce more power per square foot, so they're great for homes with limited roof space. They also tend to be the most expensive. Next are polycrystalline panels. You can usually spot these by their blue, mottled appearance. They're made by melting multiple silicon fragments together, which is a cheaper process. As a result, they are less expensive than monocrystalline panels, but they are also slightly less efficient. You'd need a slightly larger area to produce the same amount of power. Finally, there's thin film. These panels are made by depositing a very thin layer of photovoltaic material onto a substrate like glass or metal. They are lightweight, flexible, and the cheapest to produce, but they also have the lowest efficiency. Their flexibility makes them suitable for unique applications, like on RVs or curved surfaces. But for most residential rooftops, monocrystalline or polycrystalline are the go-to choices. So, we come back to the big question. Are solar panels actually worth it? The answer is, it depends, but for more and more people, it's a resounding yes. A decade ago, solar was a pretty niche and expensive investment. But today, the cost of solar panels has fallen dramatically, over 80% in the last 10 years. In many sunny areas, installing a solar panel system can pay for itself through savings on your electricity bill in as little as 7 to 10 years. After that, the electricity you generate is essentially free. Government incentives and tax credits can also significantly lower the upfront cost. To make solar even more powerful, you can add batteries to your system. This allows you to store the excess energy your panels produce during the day instead of sending it back to the grid. You can then use that stored energy at night, or, even better, during a power outage, giving you true energy independence. As technology improves and costs continue to fall, going solar is becoming one of the smartest financial and environmental decisions a homeowner can make. So there you have it. Solar panels work by using the photovoltaic effect to turn sunlight directly into electricity with no moving parts and no combustion. Silicon cells with an internal electric field capture photons, knock electrons loose, and create a DC current. An inverter then converts that into the AC power your home uses. It's a clean, elegant, and increasingly affordable way to power our lives. If you're considering going solar and want to figure out your potential, I highly recommend checking out some of the monitoring tools and solar calculators available online. I've left links to a few of my favorites in the pinned comment below. They can help you estimate your home's solar potential and financial savings. Thanks for watching. If you found this video helpful, please give it a like and subscribe for more deep dives into renewable energy. See you in the next one.